Then let's move to the next series, which is the 5D series. The 5D series starts from lanthanum 57, then we have 14 elements placed separately in the F block, and then we have hafnium, which is 72, then we have tantalum 73, tungsten 74, then we have rhenium 75, then we have osmium 76, iridium 77, platinum 78, gold 79, and mercury is 80. So this is how we have series starting from lanthanum, which gives a break in between, because from 58, cerium 58 to lutetium 71 are placed separately in the F block, which is called 4F series or lanthanoids, because the series starts from lanthanum. So this is how we have the 5D series being filled from lanthanum to mercury, atomic number 80. So this is what we have, the 5D series. We also have a 6D series. 6D series, that's an incomplete series. The series starts from, of course, actinium 89, but then we have a gap of elements, 14 elements, like from thorium 90 to lawrencium 103, we have the 5F being progressively filled. That's why it's placed separately, and that's why these are called actinoids, because the series starts from actinium. And then we have rutherfordium 104 and onward elements, which are also named by IUPAC as by their not common symbols like un, nil, bi, tri, like those numbers. So, and after this, what we say, the series is almost as incomplete. The reason being, all the elements which are lying after this, which are called post-actinides elements are actually artificial and are not known as such existing in the nature. So this is what is the general introduction of these elements. Now, before moving into the physical properties of these elements, we must give you an idea about, you must know that D block elements are also called transition elements, because their properties transits between S and P block elements. Now what that exactly means is that for some properties they resemble with the S block elements, and with reference to some property they resemble with P block elements. So their properties transits between the two blocks, that's why they are called transition elements. But remember, few of the D block elements are also called non-transition elements, or they are regarded as non-transition elements. Example, zinc, cadmium and mercury. The reason is because their n-1d suborbits are completely filled. So the d electrons are not available in these elements for reactions. So it doesn't show any d orbital characters. That's why their behavior is very different from the rest of the d block elements, and that is why they are called non-transition elements. So what we find is, for being a transition element, the n-1d must have 1 to 9 electrons. The moment it becomes 10, those 10 electrons will not participate in the reactions like what we find in case of zinc, cadmium and mercury, and that's why they are called non-transition, whereas the rest of the elements are called transition elements.